Hi everyone. Okay, so with our last quiz, there were a couple questions on there that seemed like they were a little bit challenging, and I know I wanted to make them a little bit challenging in the first place because I want you guys to apply the concepts that we learned in the PowerPoints in the videos. But let's go over some of these challenging questions, the ones that seem to sort of throw some of you guys off. And then we'll just sort of work through them, and I'll show you why the answer is what the answer is. Okay, so first we have this question here. I don't remember exactly what the number was, but I'm sure when you read this, it'll be familiar. Okay, so a study is designed to evaluate job stressors and satisfaction among community health workers, who often carry a heavy burden to provide health care in rural and low-income areas, yet have little or no professional training. The study aims to understand their challenges to then design interventions to better support them. The study gathers demographic information on community health workers, including age in years, gender identity, and educational achievement. So less than high school graduate, some college graduate, postgraduate. So these are like the different levels of education, like what educational level you are. So, and obviously we know what gender identity is or what options we have there. And then we have age in years, which is, 1 year, 2 year, 3 year, 4 year, 5 year, 6 year, like that, right? So our options, sorry. And then what it's asking is which different variable types do those three variables, remember age in years, gender identity, and then educational achievement, so which variable types do they fall under? Okay, and these were our answer options, okay, for that question. Now, I think everyone kind of understood that number 2, or this option right here, is definitely not the answer, because very, very few people chose that one. What I saw was that these three were kind of evenly distributed amongst you guys. So there's a good amount of everyone choosing those 3 answers. So let's go over them and see why the answer is ratio, nominal, and ordinal. Okay. So all of this information for this question is in lesson 1.1. Okay. All right. So now we're just going to look at the different the different variable types. All right. So we're just going to go through that, and hopefully it'll kind of click to, as to like which variable was what. All right. So let's look at ordinal. Ordinal. So ordinal is the type of variable where they are ordered categories. Okay, they have a natural, it's a categorical kind of thing. It's not a measurement that you're going to count or measure and all that. No, this is a variable that is a category. Okay, so they really don't have much to do with numbers in this. They can, but many times it's not really going to have anything to do with numbers. Okay, it's not a measurable type of a variable. But ordinal typically does have an order, okay, a natural order, like this category comes before this, then this category, then this category, then this category, then this category. Okay, so there's a natural order to the different categories. So it's really good to use ordinal variables, like if you want to do rankings, like let's say like on Yelp or something, if you want to give a restaurant or a store a certain star rating, okay, like, so it really works. It works really well with that, because it can be like 1 star, 2 star, 3 star, 4 star, 5 star, and then you tell which ranking that you think that restaurant falls under. So it's really good for those type of studies. All right, and that some other things that you can use ordinal variables for are also student letter grades. Okay, because you know how it goes, it could be like F, D, C, B, A, so there is an order, even though it's not really like a number measurement. All right, So ordinal, that is a qualitative variable. So qualitative, remember qualitative, they study qualities. Okay, they study quality, not quantity, which would be a measurement. All right. Okay, so natural order, ordinals. All right, now let's look at ratio. Okay, so ratio, that is definitely going to be a measurement, so it's going to involve numbers. Okay, and so when you look at them, really, if you want to compare like the different quantitative, because this is a quantitative variable, all right, so it's going to have measurements. Okay, and really we only had two to work with, right? We have our ratio and we have interval. If you compare the two, the main difference is going to be that ratio has a true zero. Okay, so when it has a true zero, the zero actually like means something. It usually means, well, zero can mean, you know, like the time before, like the actual time of the study starts, or just, you know, if you want to zero something out. Or it can also mean if zero is a reading in your study, if zero is an actual reading, a measurement reading, then it can mean, like if you're doing blood pressure, 0 blood pressure would probably mean that the patient is, you know, not alive. Okay. So, or you like 0 platelets. If you're doing platelet counts and you're measuring that, well, if you have 0, then that person is not alive. Okay. So 0 can actually mean something in a ratio variable. But one thing that it cannot do is it can't go lower than 0. Okay, you can't go the other side of the number line. All right, so we cannot have negative numbers. You can never have negative readings in ratio. So some examples that would actually fit into like a ratio type of variable situation could be, of course, blood pressure, because you can't have negative blood pressure, right? You can't have negative platelet counts. Okay, that's impossible. You can have 0, but you can't have negative. All right, what else can't you have negative for? You can't have negative time. And that's a huge one, because when you do a lot of studies, many times you measure against time. All right, or time is like your constant in your study. So time is a huge one, and that's one of the main major variables in a ratio, or what's one of the major ratio variables that can happen. So time is huge. You can't have negative time. So that's a big one. All right, let's move on. So yes, it can go, temperature can go below 0. That is why it is a really good interval variable, quantitative variable. So really anything that can go negative is definitely going to be an interval measurement, an interval variable. And it doesn't always mean that you're always going to have negative readings, but just think about it when you're looking at the variables and go, if it were to go negative, would that be practical? And if the answer is yes, then it's probably an interval variable. It can't be a ratio variable. So it wouldn't be able to be time or anything like that. But exam scores, that's another one that it could be debatable. But see, the thing is that can't we have negative, you can get minus points sometimes, especially in standardized testing. I don't know if they still do this, but back in my day, the SAT, you could actually get negative points. You could have points docked from your score if you answer a question wrong. And so just theoretically, if you can get negative points, if you can have points taken away from you, then you can essentially, if you got everything wrong, you can have a negative exam score. Okay, so that is why exam scores, they can be interval. They can be interval variables. Not all the time. If it is a certain type of exam where you can't have negative exam, you're not going to have negative points, it doesn't dock you any kind of points, then obviously that would not be a practical variable to here. So exam scores may or may not be interval variables. They could also be ratio variables, but you really just have to ask yourself, is it practical for this variable to have a negative number? What would that mean? What would that look like? You know, and if the situation is it's completely impossible, you can't, just kind of like as if we're looking at time, you can't have negative time. That's impossible. So time can never be an interval variable, but exam scores can. You know, if it's a situation when they're docking points for you, if you get a wrong answer, definitely can have a negative score, even though I doubt that you would, but theoretically it's possible. Anyway, moving on. Then let's look at nominal. Okay, the last one. Nominal, this is a qualitative variable, so we look at quality. Okay, we're not going to look at any kind of measurements, no numbers, nothing like that. So it's a qualitative variable. It's a categorical variable. Okay, same thing. That's what a qualitative variable does. It's like a category. Okay, ordinal is also a category. But the difference with ordinal and nominal is that with ordinal, there is a natural order to the categories that you have. With nominal, there is no natural order. They're just there. Okay, they just exist. They're there. Nothing's better than the other one. They're all indifferent. They're just categories. All right. So some examples of what a nominal variable can be could be like, different colors. What if you're doing a study where you just want to look at the see what people can, I don't know, maybe you're looking at color blindness or anything like that, and you need to use different colors to see what people can see, I guess. Anyway, the colors, they don't have a natural order. There's no one that should go ahead of another or anything like that. They're all kind of indifferent. They're equivalent in their own way. So yeah, different colors if you just have red, blue, black, yellow. If those are your colors that you're looking at, those are categories, but there's no natural order to them. There's no big to small or anything like that. Okay, whereas in an ordinal variable, there could be big to small, small to big. There could be something that related to time, maybe like this comes first, and this comes first, and this then this comes next, and this comes next after that. So there could be a natural order to it. So anyway, some other examples of nominal variables could be marital status, married, single, married, widowed, or it could, because neither of them really come before the other, right? Because you could have been married before and you're single again, so it really doesn't matter. You don't have to, there's no natural order to that. Same thing with makes and models of cars. Like you could do a study where you're looking at cars and it could be like Toyota Corollas, Honda Accords, such and such, and there's no natural order to that. It can go anyway. Okay, so what type of variables are the ones that we're supposed to be looking at? So the variables that we're looking at are age in years, okay, and then gender identity and educational achievement. So let's look at age in years. I kind of put together some questions that you can be asking yourself when you need to figure out what type of variables these are. All right, so just some real quick, simple questions that you can ask yourself just to sort of direct where your focus is going to be. All right, so if we're looking at age in years, age in years, that would be time, right? That's a measurement. Okay, so that's time related. That's a time. All right, so age in years. Is it a measurement or is that categorical? Okay, and the answer would be that it is a measurement. Okay, age is a measurement. And then the next question that you can ask yourself would be, can there be negative measurements? So can we have negative measurements in years, a negative age? No, right? You can't be like, I'm negative 5 years old. Yeah, you can't do that. That doesn't exist. Okay, so no, you can't. So if you know that it's a measurement, you obviously know that it's quantitative, and the only options there would be interval and ratio, right? And since there can't be any negative measurements, so it definitely cannot be interval, it's got to be ratio. Okay, next. Now let's look at gender identity. Okay, so gender identity, that's definitely a categorical one, right? So is it a measurement or categorical? Well, it's not numbers. It's not a measurement. You can't measure your gender identity. It's categorical. It's a category. It just is. Okay, so if that's the case, we know that it's a qualitative variable. We know that the only options are now will be nominal or ordinal, right? So we broke it down to those two. Now, what's the difference between those two? Well, the major difference is that is there a natural order to these categories? Since we know we're dealing with categories. Gender identity. What are your options there? Female, male, like all the different options there. So is there a natural order to those gender identity options? No, there isn't. It's not like it goes from big to small, or it doesn't, there's no natural order to it. You can just kind of place them wherever you want to place them, So if you put them all on the x-axis, you could write anyone where, you know what I mean? So you could put all your gender identity options on there, and there's no natural order to them. So if that is the case, what type of, it's either nominal or ordinal, right? No natural order, it's got to be nominal. So nominal would be the answer for that one. All right, so educational achievement. All right, so now is educational achievement, would that be a measurement, or is that going to be categorical? All right, are we taking measurements of the educational achievement? Are we measuring it? No, we are not. It's more of a category, okay? So there's no numbers involved. It's a category, and the categories here are going to be like high school, college, post-grad, no high school. And so is there a natural order to those categories? Yeah, there is, right? There's a natural order there, because you can go no high school to high school, then to college, then to graduate school, then to your doctorate, then to postdoc. Like, there are different levels of education, right? So there's a natural order to education, or to like your educational achievement categories, right? So this would be ordinal, right? Yay, we figured it out. Okay. So next question. Sometimes when a researcher chooses to utilize convenient sampling, they may leave some individuals out, and as a result, the sample is not a good representation of the population. The type of selection bias that occurs in this situation is... All right, so you guys remember this question? Well, when I went back and I kind of looked at the stats of your answers, I got a decent amount of people saying under coverage, which is a good answer to this question, if I might add. Under coverage, between that says under coverage. All right, and then the other answer that we got a good amount of people choosing was sampling error. Okay, so it seems like you guys are pretty much, it was pretty much even with these two different answers. All right, so that's where you guys are. All right, so let's go ahead and take a look at this. What would it be? Under coverage or sampling error? All right, so let's define them. All right, so under coverage is a type of selection bias. Well, duh, we already know that. It occurs when some of the members of the population are inadequately represented in the sample. Okay, so Sometimes not everyone that is part of your sampling frame gets to be included in your list or is included just in your sampling, in your surveying, all right? Depending on what type of sampling methods you're using. But so how can this even happen? Well, here's an example. What if you're doing a study about the faculty on campus, something to do with the faculty on campus, and so you're asking HR for a list of all the faculty on campus. Well, what if they haven't updated that list recently, this quarter? Maybe they update that list only once a year or something. So it could happen where it doesn't actually include any new faculty in that list, and it also, they have not eliminated, the faculty that have already left the school that no longer teach there. Okay, so if that's the case, then what you're going to have on that list is a bunch of people that don't even count for your sample, and then a lot of people that should be included in your sample but are not being counted. All right, so that is under coverage. You're not covering, you're under covering everyone in your sampling frame. Okay, so you're leaving people out that should be included, okay, because you need enough people to represent the school, okay, the faculty members at your school, but there's a bunch of people that you're missing. And here's another example, okay, and this is more of a convenient sampling example, so it should probably give you guys a better perspective of what's going on here. So let's say you're doing a study about local grocery shoppers in the city of San Bernardino, which means your sampling frame, okay, should include people who go grocery shopping in the city of San Bernardino, which is what, pretty much everybody. So there's a lot of people that you need a good representation of. But what if you decide to do convenience sampling because let's say you just live on campus and you don't have a car, okay? So the closest grocery store to you would be the Ralph's on University Parkway. So let's say you decide that you're going to survey the shoppers at that store. Do you see how you're definitely not going to get a good representation of all of the grocery shoppers in the city of San Bernardino? And that's because not everyone's going to go to that store, okay? Also, not everyone is going to go to that store at the same time that you decided to do that survey. Okay, so you're going to get a terrible representation of San Bernardino, of the people who go grocery shopping in the San Bernardino. Okay, you're leaving a lot of people out. So many people out. So your sample covers not much. All right, and there's a lot of information that you're going to be missing out in that particular study. That would be a terrible, design, actually. So, and then sampling error. Well, what is sampling error? Sampling error is that there will always be some sampling error. So it's the idea of just knowing that you will always have some just natural sampling error that will happen naturally because you're not taking a census. You're not taking exact measurements of every single person in that population. You're just taking a sample. Okay, so you're just taking, you're trying to, of course, get a good sample to represent everyone. You're trying to do your best to represent everyone in your population. But the thing is, there's always going to be a little bit of error, and since we already know that, you have to naturally account for that. So sampling error, just normal sampling error, that's something that will always happen anytime you do a sample. Okay, so to answer this question, it would not be sampling error. Okay, sampling error that's something that you just always know that you're taking a sample, so it wouldn't really be anything very significant. But for this particular question, what I'm trying to show everyone is that if you're doing convenience sampling, it's really easy, so easy to have under coverage. Okay. All right. So last question, the third one, this one in particular. So the answers on this one were actually pretty evenly dispersed. Again, on this one. Okay, so let's look at this question and break it down a little bit. All right, so we wish to evaluate whether there is an association between number of days missed from school and self-reported depression symptoms in high school students in the United States. In the United States, this is key, okay? I want you guys to remember that. All right, so you're looking at high school students in the United States. That's the entire country. Okay, what's going on with these high school students here? All over here. All right. Okay, so there are approximately 16 million students enrolled in public and private schools, grade 9 through 12, in the United States. All right. So that's pretty much what we're dealing with. We need a sample from this 16 million. Okay, keep that in mind. All right, so there are just under 300,000 students enrolled in private and public high schools in Massachusetts. All right, well, that's just one state though. All right, let's move on. And there are 85,000 students enrolled in public and private schools in Boston, in one of the cities of the United States. That's very relevant, huh? So what would a good sample for high school students in the United States be, and what sampling method would you use? Okay, so let's go on. How do we want to approach this question? What are we trying to find? Well, we are trying to find whether there is an association between the number of days missed from school and self-reported depression symptoms in high school students in the United States. This is the part that this is the part that has to do with our sample. Okay, so we're trying to find a sample for that. What's the sample frame here? The high school students in the United States. That's your sample frame. That's like the population that you're trying to like pick a sample from. Okay, so what information were we actually given? All right, so we were given that there are 16 million students in the United States, there are 300,000 students in Massachusetts, and 85,000 students in Boston. These two may not even be relevant information. Okay, so let's move on. All right, so we need a good sample that will represent the students in the United States. That's what we're really focused on in this question, all right? So if we use a sample from Massachusetts, would that represent the students in the United States, do you think? If we take a sample from just one of the states in our country, all right, in the whole United States, there are 50 states here, all right, and there's a lot of people in New York, California, and Texas, so I'm just saying, do you guys think that would really be a good sample to represent all the students in the United States? Because you also have to take into account there's a demographic difference compared to all the other states. Okay, there's going to be culture difference. There are going to be a lot of other variables associated with that. So it would be really difficult, actually, to use only the students in Massachusetts to represent everybody. Because we're not, in this entire country, we're not that uniform. Okay? So, next, if we use a sample just from Boston, would that be a good representation of the students in the United States? Just because you bring it down to just one city and we'll be like, we'll use that. That's what we're going to use. It doesn't really, it's not going to represent everyone in the United States. It's just going to be a good sample for Boston. It's going to be a good sample probably for Massachusetts or maybe the urban areas in Massachusetts, but it's a terrible representation for the United States. Okay, for everybody here, we have so many states that are not being accounted for and not represented in that sample. So that would kind of be a terrible sample. All right, so we need a sample that's going to represent all of the students in the United States. Okay, so let's look at all the answer options that we had. So first of all, we had, well, this was the correct answer, but the optimal sample for the study would randomly select high school students from across the United States. Okay, randomly select, just at random, okay, select high school students from all over the United States. That sounds like a really good representation of the United States, just taking a little bit of everyone from all over the place. Of course, you would have to get really into the details. This is more of a higher level statistic. If you really want to get into how you're going to find that how you're going to randomly select them. But just looking at the surface, just as a good test question, simply that's all you need. You need to randomly select high school students from all over the United States because your study is about students from all over the United States, right? So anyway, let's look at the other options and figure out why they're not really up to par with this one. So the population size should be at least 85,000 to represent students from all cities in the United States. Well, the sample size isn't as relevant as making sure that the sample includes representation from everywhere. Although that does sound like a pretty decent size given the fact that we have so many people. So, what was it? 16 million students in the United States. But it's not necessarily, it may or may not be the best sample size. That's really not relevant. That's not what we're trying to figure out right here. Okay, so we're looking at more of like what the sample, we're looking at representation. Okay, that is what we are more focused on in this question. All right, so next answer, the optimal sample for the study would randomly select high school students from Massachusetts. If you select high school students from Massachusetts, you would leave out representation from 49 different states. Okay, and that's a lot of people. There's so many people. Compare that to, like, we looked at the information on the previous slide where there were only 300,000 students in Massachusetts versus 16 million in the whole country. So that's not the best representation, especially knowing us, knowing our country, and knowing how different all the states are. Okay, so it's going to be a terrible representation of everybody. Next answer choice was a study sample that includes all high school students in Boston would be an ideal sample for the study. So that's even worse than the previous answer, because if you're only looking at Boston, that's an even lesser representation of all the students in the United States. All right, so that's only, what was that? Like 38,000, 85,000, something like that. Yeah, it was 85,000 students in Boston. That's an even smaller representation. So if you're randomly selecting Boston students, there's no way that Boston students can also represent, students who live in like Needles, California, okay, or San Diego, or going up north, or anything like that, right? So that would also be a horrible representation. There's terrible undercoverage happening in all of these options, or in these two options, there's terrible undercoverage. And then right here, it's just, that's not where the focus is right now. We're looking more at representation and making sure that there are at least 85,000 students to represent all the cities in the United States. May or may not be the best size option, but figuring that out would be a higher level, a more sophisticated level of statistics, so we don't really need to worry about that right here. So if there are any questions, please let me know on this. I hope this clears things out for you guys. You will see these questions again, okay, like on the midterm and whatnot, so make sure that you understand them and you know what you're doing. You'll see questions, you might see the same ones, but you also might see questions that are similar, Okay, we're taking the same concepts, but I'm just going to put them to different, words, different questions. Might be asking the same thing, but in a different way. I might have a different case study, a different scenario. All right, so similar stuff. You'll be seeing this a lot, so make sure you guys understand this.